Now let's say we solve some problems, and problems are here from the book. Let's say this is problem 1.43. Solve problem 1.43, and it is on a Dirac delta function. Let me solve the first, this one, which is integral from, means this is part A of the problem. I will not sort all parts, but will briefly discuss them. This is 2 to 6 here, and function is 3x square minus 2x minus 1 and delta of x minus 3 and dx here. So now this is 3 here, and it is in this range from 2 to 6. So it is right, and for x we will write 3 here. So this will be 3 and 3 squared minus 2 and 3 and minus 1. So this is equal, 3 3s are 9, 9 3s are 27, and then minus 6 and minus 1, so minus 7, and this is equal to 20. Part B here is from 0 to 5, and cos of x delta, and it is x minus pi. Now this pi is in radian, so dx, and pi in radian is 3.1416, and it is in this range, so it means this is cos of pi, and cos of pi we know that this is equal to minus 1 when pi is in radian. Similarly, part C here, part C is 0 to 3 and x cube delta x plus 1. This thing we already solved just a moment ago, that this I will write is x cube and delta x minus 1 and dx here. So integral from 0 to 3. Now minus 1 is not in this range, so it will give us 0 here. Similarly, the d part is from minus infinity to plus infinity, and log of x plus 3 and delta of x plus 2 dx. It means it will convert into delta of x minus 2. So we will write minus 2 for x, and it will become log of 1, and log of 1 we know that this is equal to 0. So this is the reason that minus infinity to plus infinity, minus 2 is in this range, and we got this thing equal to this. Now the purpose of solving these problems is to understand that how the Dirac delta function works and how things can be calculated. Similarly, in problem 1.44, we are given some integrals based on Dirac delta function. This is integral from minus 2 to plus 2 and 2x plus 3, then delta of 3x here. So this is dx. Now I will have to first simplify the integral. The very first thing I will have to write this one. This is delta of the one that we solved earlier, the delta of kx, so it will become 1 over k absolute. So this will be 1 over 3 absolute, and then we can write delta x here, then from -2 to +2, and it will be 2x plus 3 delta of x and dx here. Now at x equal to 0, we will write this thing. So it is equal because 0 is between these two. So we will have for x equal to 0, this will become 0 and this will become is 3 here. Similarly, in the next problem, we are given with this was part A. Now in part B, our delta function has been changed and it is from 0 to 2, and x cubed plus 3x plus 1, this is plus 2, and delta of 1 minus x dx here. Now I will write this one is delta of x minus 1, and we know that delta, when I will have to take minus sign from it is common, then it will become like this. But I know that delta of minus x is equal to delta of x, because this thing I write from that delta of kx, like this one is treated as delta of kx, k being minus 1. This is 1 over k absolute delta of x. So minus 1 absolute, it is plus 1. So delta of minus x equals delta of x. And then it will be equal, for x just put 1 here because 1 is in this range. So I will have this thing equal to 1 cubed plus 3 plus 2, and it will be equal to 6. Similarly, in part C, we are given is part C here, and part C is from -1 to +1, and this is 9x squared delta of 3x plus 1 and dx here. So the very first thing here, that I will convert this 3x into x. So I will utilize this relation. It will become 1 over 3. Then I will have this range as well. So it will also be converted. So it is better to have 3x plus 1 equal to something. Like I suppose here that 3x plus 1 is equal to y, and then I will write the dx will be then equal to 1 over 3 dy, and then it will be y and x will be converted from here, that x is equal to y minus 1 over 3, and then dx will be y dy 1 over 3 dy here. And what about the limits? We will calculate the limits as well. When x is -1, then what about y? What y will be? So I can calculate the limits here as well, that what will be the limits. When x is -1, then this is -3 plus 1, and y will be then equal to -2 here. And when x is equal to +1, then y will be equal to 3 plus 1 and equals y, and it will be equal to +4. So our limits will also change here, and I can write that integral from when x is -1, so it is -2 to plus 4 and 9x square, so 9, and for x I can write y minus 1 over 3 whole square, then delta of y and dy, so 1 over 3 will come here and dy. And now I hope that you will be able to solve this one, because take this 1 over 3 out, take this 9 out, so it will be just 3, then y minus 1 square, and I can write it here that then this is equal to 3 times, because 3 it simplifies with this, then y minus 1 over 3 and y minus 0, 0 is in between this range, so I can write that for y equal to 0, and this is 3, and we will have y equals 0, so 0 minus 1, this is minus 1 over 3 and whole square, so it is 1 over 9. It is 1 over 9, and then the whole result comes out to be 1 over 3. Similarly, the D part is comparatively simple. The D part is that integral from minus infinity to a and delta of x minus b dx. Now here it has not been specified that what is b, whether b is coming after a or b is coming before a. So generally if I think, then b will be coming after this one. So from this is from minus infinity to all range is a, so this is now conditional as well, that if b lies between this, then we will have its result, but if it lies outside, then its result will be equal to 0. So it is to be specified first very clearly, and then we can solve this one. As a general look, it will be equal to 0. So I can say about this one that if b is less than a, means this is in this range. If b is less than a, then this will be equal to 1, or if b will be greater than a, then it will not be in this range, so it will be equal to 0. So it is to be defined first that what this will give us. Similarly, this is another important problem. It's rather a corollary to prove. This is problem 1.4 and 5. This problem is saying that show that x and d over dx of delta x is equal to minus delta x, and it has given us a hint to use integration by parts. Let theta, and part B is saying that let theta x be a step function. Theta x is equal to 1 if x is greater than 0 and 0 if x is less than or equal to 0, to show that d theta over dx is basically delta x. We have already proved this in the gradient theorem, that or in the fundamental theorem of calculus, as well as in the gradient theorem, that when a function is such that it is already a derivative of another function, then we can directly write this thing is the derivative outside of it. We have already done this one, so I will do this part A, and this is x delta x d over dx of delta x, and prove that this thing is equal to minus delta x. So this thing is easy. We will do integration by parts, and the very critical thing over here, that we will select our function first and second in a way that it comes out to be like this. We know Now let me solve this one. Let's say I just combine a function with this, and this is f of x and then x d over dx of delta of x, and let's say let me write this thing, then it will be further dx here, and it is the integral from minus infinity to plus infinity. Let me write this one, the d over dx of delta x is delta prime x, so it will be easy. Now here, let's say I select this one is my first function and this is my second function. So I can then write that first function, which is x f of x into integration of the second function, and that integration of the second function will be like this is prime of x, so if I will integrate this, only delta x will remain delta x, and its value at minus infinity to plus infinity, and we know that when x will be equal to 0 it will give us value, so this whole term goes to 0, and then we are having minus, then whole integral from minus infinity to plus infinity, and we are having the derivative of the first function, so we will have d over dx of x f here, means f of x I am writing is just f, and then the integration of this one, and it will come out is delta x dx of this integral as a whole. So now I can expand this portion, that what will be df over dx of this. So d over dx of xf will be first function into derivative of the second, df over dx, and plus second function into derivative of the first, and it will be equal to 1, so it will be just f. So I can write here for this one that minus integral from minus infinity to plus infinity, and d over dx of xf. So I can write this thing is x df over dx plus f and delta of x in dx here. And when again I will solve this one, so I take means this one with this, so it will be integral minus from minus infinity to plus infinity x df over dx delta x dx minus integral from minus infinity to plus infinity and f of x delta x and dx here. So now if I look at this one again, what will be the result if I take this one, means first function into integration of the second function, and when this will come, it will be again coming this situation, because the integral of this one will come f of x and d of x, so this term again goes to 0 here, and we are left only with this one. And what is this thing? This is equal to minus f of 0, because it will only give value when x is equal to 0, f of 0, and this minus f of 0 is basically this one. If I take this thing out of it, then this is minus delta of x. So this is minus delta of x, and this thing implies that x d over dx of delta x is equal, like this thing is x delta prime of x is equal to minus delta of x, and hence we have proved that corollary as well. That is in terms of problem 1.45.